apply that. Maybe even use it as a utilitarian library for your product and just make everybody use that descriptor, right? Or even set the default DACL for the process, not even worry about it. Everybody will create using that from now on. It's very easy to solve these problems. Whereas, you know, you're less 10 lines of code and all the objects there are secured. If you don't supply one, then the DACL is taken from the primary token of the process owner. So what's called your default DACL, which on modern operating systems, at least modern NT, is administrator, system, and the owner of that process. So if it's administrator, you're usually pretty safe for most parts. You get back into XP and some other systems, things change, right? So you see this panel all the time when you're configuring objects in NT. Nobody has ever written this in their products. This is a common interface called Edit Security and Create Security Property Page, and they just call this. This is the same thing. What's interesting about this is it's a generic set of permissions for each object. When every object has their own permissions, their own giant subset that are set. You can't touch any of those here. So I think it's interesting. It's all hidden from you. And because this is so nice and clean, people just reuse it everywhere. And a DACL, which we've talked about, I think at this point, everybody gets that. So, yeah, it's a common practice that instead of creating a default DACL, you take the existing one. So the process, you get that from the token, and you add an entry to it for like everyone, for example, and then you use that. That's kind of how people do things. So this is really interesting with default DACLs. And another thing anyone's really touched on before. So when someone creates this default access control for an object, for an application. Now, imagine a scenario where there's an RPC service that, you know, your favorite CD player software installs. And it sets set default DACL to allow everyone. But it's loaded inside the SVC host generic process. And every object and every system process in that will now create objects with poor permissions. So another thing. Or like an Internet Explorer plugin or toolbar or Firefox or any other application. So we used to define protected objects, like an access check. And if you download that, you can check it out. I think this guys have some samples how to run it in different applications and different types of objects to find weaknesses. Unnamed objects. This is kind of interesting. So certain unnamed objects in Windows are actually forcibly named. Even though you don't declare a name, you don't want them to be named. They're named anyways. And they're accessible, too. They're accessible globally. So I went and dug around in RPC runtime, and I found where they create the name. They just generate a random number, 9 digits in length, and that's the name. And if you saw earlier when I had that RPC controls and that directory view, if you click on there, you see all these random names. And those aren't special controls. They're things that people created, not intent to be accessible remotely or locally by their applications, maybe besides a known app or trusted app, but they are here. So you can query those with remember Todd saying with a bind view wrote a tool called IFIDS a while ago. That you can feed an endpoint and query it. And those are all the interfaces listening on the endpoint. Another thing to remember is that if an object's already opened, no matter what you change to that, it's not going to change those open handles, right? It's a common. You can't do the file systems. You can't do permission checks on read and writes. I mean, performance would skyrocket problems. You can only check on open and close. So the same thing for security. When you apply it, it's applying it for future opening operations. So there's a connection to a file or name pipe in place. For whatever reason, it's not going to apply to that. That's kind of common knowledge, I guess. But so object squatting is another interesting way of escalating privilege. I think it's to work on anything with a global registry for objects along those lines. So first, let's go into some privileges. There's a couple here that are important to know. This SE create global privileges, or a privilege, is a privilege that was put in place to prevent people from creating shared memory in the global area. Because apparently there's been problems with this, right? Because you can create a shared section of memory, have someone else use it, and obviously it's going to cause a problem if you have names of directories or functions to call or things. Data structures that are there, rather. If you're in session 0 of the services, session, you can do that. But you can still create all the other object types that are there. It's just an interesting thing to know about. It's there. Symbolic link privilege, another one. Only admins have this privilege, so you can't create symbolic links. So the reason I lead into this is you see this kind of patchwork that's been done. Not a global solution, but this is a problem, let's add a token here. This is a problem, let's add a token here to access this over and over. And each time a new one pops up, you add another feature. Right? Not a general solution, but for these. And that I would imagine because so much of the software out there relies on the way it works, you can't change the access control model. Everything would break. This is a key part of the operating system. Yeah, as I mentioned here, it's like LPC ports, pipes, events. There's a whole ton of objects. We got 2 there out of 36, right? So it's a lot more to work with. So object squatting. Non-administrative users, as we know from our permission check before, can create objects in base name objects and RPG controls. So a rogue user can create an object that masquerades as a legitimate object with the same name, because the authentication doesn't exist. It's done by name for identification for that object. You can disrupt users, potentially escalate privilege, who knows what else. So I'm going to demo for this one as well. So what I've done is I took the DNS Resolver built into Windows, and I decompiled the IDL stub code out of it into an IDL and fixed it up, and then rebuilt it into a fake DNS Resolver, right? And I'm going to run this as a limited user with no privileges. In theory, my object should be created in RPC controls because I can write to it. And I'm going to advertise interface there, and callers will go to that object, and they specify what's called a connection sequence, name pipe, endpoint, local RPC, and RPC. It'll go to my name, which is DNS Resolver, and then go over to my process and a notification of who I am. So let me switch over. These 2 sessions get me confused sometimes. I'll have to switch back and forth. Okay, there we go. So, my own DNS service here. This binds the resolving endpoint, or creates my own resolving endpoint, advertises it, and waits for people to do a lookup through the endpoint mapper or somehow call that protocol sequence and come through to me. So I'll switch over to my administrator session again. And now if I do a ping for like google.com or anything, oh, it's just completely broken. Let's see here. Uh-oh, that's not good. Let's switch back over and see what's going on. Yeah, it turns out that faking RPC service with my own IDL has been challenging, at the least. Oh, it's getting a request, though. Here, so we can see this coming through. For some reason, this doesn't decide to work. Let's do this. We'll do a run as. There we go. Oh. I was translating to Riley, that's right. This name aliasing is so frustrating in Vista. There we go. Alright. So let's try here. We'll do a ping for google.com as an administrator. See, they're routing through for some reason. DNS Resolver. I think I've just broken it so many times now that my machine has just threw it all together. Let's see here. Okay. Well, I think one of the demos. Can I flush it? I gotta love that. Okay. Well, so my demo failed. I think it was going to happen at least for one of these. But you guys can see how it's communicating with the endpoint. It's just my poor ability to process structures coming in, apparently. That's causing a failure here. It's worked every day but today. Okay. Object squatting and impersonation. So, this is something else that's interesting. The SC impersonate privilege in Windows won't allow you to impersonate people calling into your code, right? Unless you're a higher privilege. This is done, if you guys remember, AtStake did. Actually, Andreas June, one of the guys at iSec. This is back, I think, 6-7 years ago. found you could knock down a service and then create a named pipe, the same pipe as a service like